So now we actually get into the part where we have to complete the square. And the wording from this comes from having incomplete parts. So I'm going to sketch some of this stuff. So let's say I have x squared here. And I know that it would be a square with parts on each side, and that x times x would give me that x squared quantity. But then I'd also have, something that would be x wide, but, 6 units tall or whatever. So that, that's a little bit of an issue. So what if there was 3 there instead, and 3 there instead? So I knew that x plus 3 and x plus 3 over here, that does give me the x squared term, 3x, and then another 3x. But what's really missing is this part that would complete the square. And the only way that would work out nicely is if I had a 3 by 3 section here made up of 9 chunks. Now I'm only quickly showing the visual of that, so if you want to model some of these, we can check them out. But I know that what I have cannot be factored. But there is something that I could place here that would factor perfectly. And that value is always going to come from taking half of this number and then squaring it, and 6 over 2 would become 3, and 3 squared would become 9. So there's that perfect square that I wish I had. So one more time, this is not something I can factor because I'm missing a straight up quantity. Well, this is what I want. Now here's the thing, realize this, the left side does not equal the right side, so we'll talk more about how we would keep that balance later. But this is another factoring problem, and we're going to have more tools to be able to solve these types of things. So I have r squared plus 8r, and I'm going to take half of that value, which would be 4, and then I'm going to take 4 and square it, and I'll get 16. So I had r squared plus 8r, but I want to have 16 out here. And realize this, look at the last one. The last one, I'm going to write this in red so I try to keep it consistent with what you do and don't need to record. If I had x plus 3 squared, that would have given me this term, and that term. For my second one, if I had r plus 4 squared, I would have gotten r squared, 8r, and then lastly 16. Now the only way to make this more complicated is by throwing fractions into the mix. And so maybe you're like, well, I think it's going to be y squared minus 1/3 y, but probably plus maybe like 1/9 or something. But let's go through the math. If I take 1/3, but I want to take a half of that, now notice how I said a half this time, so I could multiply it by half, that would give me 1/6. But then when I squared that out, I wouldn't get that 1/9 that I was just guessing at. I'd actually have 1 over 36. And let's make a little bit of a believer out of you. That means that I want to have y minus 1/6 squared, which factors out to be y squared, and I'm going to FOIL this completely, I'm not going to repeat it, minus a 6y, minus another 6y, and then plus 1 over 36y. So then when I put those two middle terms together, I get that minus 1/3 y plus 1 over 36. That is exactly what we came up with going through just the steps. Now you're probably feeling good here, but maybe a little queasy here. So now we're going to be told to solve each by completing the square. We look at the starting problem, and we say to ourselves, well, is this like one of the last ones where I could just nicely write it as x minus 7 squared? And it totally isn't. Which would mean that I could square root both sides, so that's not working out. So, your call. You can subtract 10 now or subtract it later. I'll do it now. because maybe I'll get lucky and it'll end up working out like one of the last ones. X squared minus 14x minus 7 is 0. So what are the factors of negative 7 that add up to 14? And there we run into another dead end. But here's what I wish it said. I know that I'm going to have x minus 7. That's going to be my desired quantity to have squared. And here's like a little proof off to the side. That would turn into x squared minus 14x. But then what would I get as a new term? Well, I get plus 49. So that means that I've added 49, and I would now have to take away 49. I fixed this to keep it from what I wanted, to keep it from changing the value. But now I'm going to show you how most people like to show this. So here's x squared minus 14x. I know that I need this plus 49, so I'm going to write plus 49. I know that I can't get rid of that 7 yet, so I'm rewriting that. But to compensate for the shift that I made over here, I'm going to add 49 to this side as well. I didn't mess it up. Now you got to go through these calmly and slowly. That and those three terms, that is what is going to give me my x minus 7 squared. So that means those three terms became this term. That does not address this 7, so I'm just going to rewrite it. And it doesn't address that 49, I'm going to rewrite it. Now I'm going to add 7 to both sides. And then x minus 7 squared will give me 56. Now these really wouldn't work out to be nice numbers. So here's x minus 7 is equal to positive or minus square root of 56. And then I'd rewrite this as x is equal to negative 7 plus or minus the square root of 56. And since they say to neither round to the nearest tenth or not, you have the choice of typing this in your calculator and getting tenths or leaving it as it is. Both will be acceptable formats. I bet that this is one of the more challenging things you've done in a while. So, definitely, see me. This is going to be a one-on-one thing to where we're going to make this feel as comfortable as possible. Okay, I got a new example. X squared minus 8x equals 4. I know that I want this to be x squared minus 8x plus something. It's always going to be plus because whenever you multiply those FOIL, those last terms, it's always a positive times a positive or a negative times a negative, so your result's going to be positive. So I'm going to take half of this value, which would become 4. I'm going to square it, and then it becomes 16. So when I rewrite this, I'm going to write x squared minus 8x plus 16 is equal to 4 plus 16. Because I can't just add 16 to one side without making the same adjustment to the other. So unlike solving, I'm adding this to help me create a factored form. Since I've written this in blue, I'm going to keep that consistent. Here's x minus 4 squared equals 4 plus 16, which would be 20. Now I can square root both sides, and I'll have x minus 4 is equal to positive or negative square root of 20. Add 4 to both sides, which gives me x is 4 plus or minus the square root of 20. Your decision again, you can either find an approximation of that or keep your answer like that. Make this an OYO problem, and I will put the work up in about 8 seconds. So hopefully you caught that you could have divided all of those 3 separate terms by 3. When I did that, I got a different equation, which was x squared minus 6x is 10. We knew that our target was going to be 9 because I took this number and half of 6 is 3. And then when I squared it, I got 9. Over here I just showed that, this is going to become x minus 3 squared. So going from this step to here, knowing what we wanted, we added 9 to both sides to keep it balanced. We made sure we didn't lose anything in those steps. We rewrote that as x minus 3 squared, took the square root of both sides, leaving us with plus or minus square root of 19, and then we just did the ladder stuff towards the end. 3 problems and an explanation as quick as this for something this challenging, that's probably not enough. So make sure that you are seeking me out for help and doing lots of one-on-one examples and going about these gradually.